All right, guys. So you might want to have out in front of you your formula sheet, the blue one, just because that way you always have it as you're working through things, as you get your homework assignment at the end of class today and you're working through stuff, you have it right there in front of you. This is one that you could memorize, but I'll be honest, even I don't have this one memorized. I have to keep looking back at it. All right, so we are working in the second row, the future value of periodic deposit investment. You're welcome. All right, we're going to give it to Noah, please. All right, so for today then, we are going to calculate the future value of a periodic deposit investment, and I'll tell you what all that means. We were going to do the graphing part, but I'm thinking I'm not going to do the graphing part. We can cross that part off. And interpreting the graph, then we won't do that part either. All right, we're not going back. Well, yeah, we're only going to do the top one. I think we'll spend enough time there with calculator issues that, yeah, it'll fill our time. All right, so let's do a bit of a review first. Before we jump into the new stuff, I want to make sure you're understanding how all this stuff ties together. So suppose you open an account that pays interest. You make no further contributions. So think about maybe when you were born, grandma invested, put money in an account for you that you get when you're 18, right? So it's just like a one-time deal. That's what we've been dealing with so far. We're talking about I put one lump sum in, and that sat there and accumulated interest. That's all we've talked about, right? So you just leave your money alone, let compound interest work its magic. The balance your account grows to at some point in the future is called your future value of a single deposit investment. This is what we've done already. This formula should look familiar. We dealt with this when we had a quiz that dealt with this formula, right? Okay, so keeping that in mind, again, just kind of reiterating what we did before the weekend. If Jimmy invests $4,000 in an account that pays 5% interest, compounded semi-annually, what is his balance to the nearest cent at the end of 10 years? So I need you to recognize, because we're going to talk today about a different type. This one is I took $4,000, I put it in account. That's all the money I've ever put in. I never put any more in it. How much is left is in there in 10 years. Okay? Just off of my initial 4,000. All right, so using this formula, again, which is the one that we learned last week. This is not new stuff today. So we're going to plug everything into that formula. So B equals, what is his principal amount? 4,000. 1 plus my rate as a decimal. Good, 0.05. Divided by n, meaning how many times is it being compounded if it's semi-annually? 2, that's twice a year. And then n, which is 2 again, and then the t, time is 10 years. Okay, and this is when you grabbed your calculator, you work some magic, and what did we find? That is correct. There is no -1 in this formula. All right, so this is what we've done previously, correct? We took one amount of money, we put it in. Now, for today, the new stuff is many people add money to their savings accounts on a regular basis. This is called periodic investments. Like most jobs, you get paid every 2 weeks. Think about it like that. Sometimes you get paid every week. Most jobs, it's more common, I think, every 2 weeks that you get paid. So like for myself, every time I get paid, mine's even different. Mine's twice a month as opposed to every 2 weeks. Yeah. So like I get paid the 10th and the 25th of every month. You get used to it. Then my husband, he's twice a month also, but his is the 15th and the last day of the month. So it kind of works like it splits, like we have a paycheck like every week, just because of how it splits. It worked out. But anyway, so like, yes, he is. He teaches adapted phys ed, special needs kids. He teaches at Perrysburg. Mr. Bob is what the kids call him. Yeah, do you know Mr. Bob? How do you know Mr. Bob? Do you really know? That's my husband. He's Mr. Bob. Gotcha. Yeah. So that's him. But anyway, back to the whole point of why I brought all this up in the first. Ask later. Ask later. Okay. So, so, anyways, I get paid twice a month. So all my paychecks, like mine's split. When I get paid, part of my paycheck goes into a separate account that pays my mortgage. Part of my paycheck goes into like my regular checking, and then part of my paycheck. Stop looking at my elbows like that. Part of no. Part of my paycheck, $100 from every paycheck goes into just a savings account. So like that means twice a month, $100 gets put in this savings account. That's just money that I don't even realize is there, but it keeps accumulating over time, right? So that's kind of what this is, a periodic investment. Stop making that face. All my joints hyperextend. You should know that by now. Thank you. All my joints, like my elbows, my knee, like they all hyperextend. All right, anyway, so that's what this is. Periodic investments. I will try not to do that again. Periodic investments, though, that's the same deposit at a regular interval. So mine is twice a month. Mine goes in twice every month, $100 every time. You could do it yearly, maybe once a year. You always put the same amount of money you deposited in. Maybe you get your tax return, you always put $1,000 in an account, whatever it is. Okay, monthly, bi-weekly. What's bi-weekly? Good. That's every 2 weeks. That's bi-weekly. Weekly or even daily. Okay, but it's the same amount always getting put in the account. Now, think about how that changes your compound interest. Because compound interest is based off of how much money is in that account at that time. They calculate the interest and they add it back on. So then the next time it takes that amount and the interest and calculates it again. But if you're always putting money in, it's changing the formula a lot. That's why the formula gets really crazy. There's your formula. Right? No, you do not have to memorize that craziness. So when you're typing all this stuff in your calculator, I really like the graphing ones for this because the graphing calculators, it will look just like this. Like you can see all those levels in the graphing calculators. The regular calculators, remember you can't put decimals within fractions in like the plain scientific ones. So your calculator, the plain one's going to have a holy fit if you try to type this in. It can be done, but the amount of parentheses that you would have to have on there, you're going to mess it up, okay? So in this case, B is still your balance. P is kind of like the principal, but it's that periodic deposit amount. So like for me, it'd be $100. I put $100 in that savings account every time I get paid. Okay, so that's my P. Notice there's 2 sets of parentheses here. You do need both. I was typing one in earlier. I was working through an answer key, and I typed it in fast. I only hit one of those. Or I think I put the parenthesis in front here on accident. Way different answer. Don't do that, okay? So we got to be very careful. So your amount here, 2 parentheses, 1 plus your rate divided by n. So that's still your rate as a decimal. N is still the number of times it's being compounded, so all that's the same. Close parenthesis, the NT, that's the same like we've been dealing with. Minus 1, and then close that last parenthesis. Notice your parentheses. This first set right in here, I didn't even touch the board. All right, this first set is this right here. The exponent is being taken to this. And then the second set of parentheses takes everything inside there and then multiplies it by the amount that you're depositing. So where you put your parentheses are very important. All right, and then you divide by, don't throw it. Then you have the R divided by N at the bottom. So you got a fraction on top and a fraction on bottom of the entire fraction. Yay, lots of fractions. I know you guys are excited. All right, let's try some of this, see how it goes. All right, Rich and Laura are both 45 years old. They open an account at the FST Savings Bank. You're in FST class. No, okay. FST Savings Bank with the hope that it will gain enough interest by their retirement at the age of 65. They deposit $5,000 each year, so every year they keep depositing that $5,000 in there, into an account that pays 4.5% interest compounded annually. What is the account balance when Rich and Laura retire? All right, now first, before we even start throwing numbers in there, I need you to recognize the difference between this type of problem and then the review one that we did to start. The review one that we did was $4,000. They just put in one time, right? And then they just figured out what the interest would be. This one, every year they put another $5,000 in. So they're constantly adding to this. So when they're constantly putting money in, it changes which formula we have to use. So we're going to have to use this formula, which I'll move it back up here so we can see it. All right, so let's go ahead and let's write it down first, and then we'll practice the calculator. And I cannot stress enough, Noah, that you write down everything. Write it down. Don't try to be that person who just types everything in the calculator. I want to see it written down first. All right, so what's the P? How much are they putting in? 5,000. Parenthesis, parenthesis, 1 plus, what's the rate as a decimal? 0.45 divided by n. How many times is it being compounded? Annually. Annually means once a year, so it's a 1. Close 1 parenthesis. N times t, my n is 1. My t, 20. Good, because they're 45 now. They want to know when they're 65. That's 20 years later. Minus 1, close parenthesis. Giant fraction. And then your rate. All right, grab your graphing calculators, practice typing it in. Okay, let me give you a few seconds. All right, so back to the problem. Just make sure we got it in our notes good. So when you type all of that stuff in, you should have gotten $156,857.11. All right. Number 2, how much interest will Rich and Laura earn over the 20-year period? How'd you figure that out? How'd you know they put in $100,000? Very nice. Very nice. Let's talk back through what Josh just did. He's correct, but let me talk through it. So if it wants to know how much interest, well, what we found is the grand total of the amount of money they put in plus all their interest all combined, which is great. We know how much money they're going to have. But to know how much interest they actually earned, well, they're putting in $5,000 every year for how many years? For 20 years. So what is 5,000 times 20? It's $100,000. So 100,000, that's how much money they actually put in the account. They're putting in 5,000 every year for 20 years. So they put in 100,000. All right, so if I want to figure out their interest, we would take how much money they have at the end, 857.11, and subtract how much money they actually put in. All right, the total amount had how much they put in and the interest combined. So if I subtract out how much they put in, all I'm left with is the interest. So they put in $56,857.11. And don't forget your dollar sign, because that'll lose you points on your quiz. Yeah, it'd be harder to retire on. I guess it depends what your plans are after retirement. Hopefully their houses are paid off. They don't have to worry about a mortgage. But I mean, that's 56 grand. That's just like free money. Think about it that way. It sounds kind of nice. Okay. Questions so far? Calculator-wise, we doing okay? All right, number 3, Linda and Rob open an online savings account that has a 3.6% annual interest rate compounded monthly. If they deposit $1,200 every month, how much will be in the account after 10 years? Again, I need you to be able to read a question and recognize which formula, because tonight's homework has the compound interest formula that we did on the review and the new one that I'm teaching you right now. So you need to recognize, are they making just one initial deposit and that's it? Or are they putting that much in continuously? Do they keep putting money in? Okay, so this one, they're putting it in every month. They're putting in $1,200. So we're going to need to use the fancy formula. Noah? Okay, hold on, Noah. Hold on. Did you write it down like I asked you to? Write it down, Noah. All right, so we know we need the fancy formula. So how much money are they putting in every month? 1,200. 12,000 a month. Whew, I got some money. All right, so 1,200, parenthesis, parenthesis, 1 plus the rate divided by n. How many times a year is it being compounded? Why 12? Good. It says monthly, which is 12 times, 12 months in a year. Close parenthesis. N is 12, and then T, 10. Wants to know 10 years. Minus 1, close parenthesis. Divided by, huge fraction, divided by 12. All right, so take some time, grab the graphing calculators. Let's try typing all this craziness in. Let's see where we end up. Don't you love all these formulas? Oh. You what? You got 0. I'm thinking you typed something in wrong. Yeah, right? The bank went belly up. All right. As you're typing things in, I want to make sure you're checking it. $173,022.87. You round correctly? All right. Double check it, guys. I want to make sure we're okay on calculator-wise, because that's hard, is to make sure you get all those parentheses in the right spot and right things, because that thing's intense. Aren't we glad the graphing calculators do fractions now? They used to not. Yeah. You're right. We could do this by hand. You gonna do it by hand? I wouldn't want to either. Were you gonna ask me how you can do it by hand? That's totally what you were gonna ask me. I could tell you how to do it by hand. I could do it by hand. I wouldn't want to. No. No, I can. It would take a long time. The part that's going to take the longest is right here. Raising this to the exponent of 120. That means whatever I get when I figure this out by hand, I'd have to multiply it by itself 120 times. I could do it. I don't want to. It would take a long time. Yeah, I could do it all in one day, provided I don't mess up. You're right. I am human. All right. Is there anyone who was not able to get this amount, though, for this problem? Okay, guys. Next part, number 4. How much interest will Linda and Rob earn over the 10-year period? All right, so first of all, we need to figure out, because this amount that we found, the $173,000, that's interest and how much they've incorporated, like everything. So how much did they actually put in? Cole? How much did they put in the account? You should have wrote it down. Not 12,000. 144,000. Because they are putting in $1,200 every month, right? So if I multiply by 12, that's telling me how much they put in per year. And then we're doing this for 10 years. Yeah, so they actually put in $144,000 of their own money. Noah?
You're actually not asking for either compound or the fancy one. You basically do the fancy one, so you can do APY.
No, we're not doing simple interest. We're not doing any formula here. If I know how much they have in 10 years, to figure out how much was just interest, I take how much they put in and subtract that from here. Subtract that from this value, and that tells me that they put in was it $29,022.87. That's how much was interest. Noah, simple interest would be I put money in one time and I only earn the same amount of interest every single time. It doesn't take into account the interest that keeps getting added into the account. This is compound, so it does take that into account, plus it takes into account that I'm putting money in all the time as well. So this, I don't need a formula to figure this part out. This is like a continuation of this problem. This is how much money we have all together in the account after 10 years. How much of it was just straight up interest? I just have to subtract off how much they actually put in. And the rest of it's just interest. All right, how are we feeling, guys? Tired and hungry. Let's skip 5. Sure, what you got in mind? All right, guys, number 5 is where this graphing part comes in, which I'm not going to make you do. But I want to show you, or at least kind of explain to you what it is. Okay, I'm not going to make you do it. But what you would have to do, if you're doing this in your graphing calculator, you'd have to hit the y equals. You know, you could type an equation and make it graph it. You'd have to type this whole equation in. Like this is the last problem that we just did. But instead of the nt up here, it has an x. That way you could find it for any amount of time. Okay? It looks like a straight line, especially because you zoom in so far. But notice like where these numbers are, 60 and then 78,000. So like the big issue with this is recognizing where your windows should be, because you'd have to change it. Because by default, your graphing calculator goes from -10 to 10. So if you would graph this and not change the window, you wouldn't see anything. It'd be blank. You'd be like, where's my graph? But the great thing about a graphing calculator, if you graph the equation, and if you want to see how this works, I will be happy to show it to you, okay? But the thing with here is that once you hit trace, I could type in any amount of, like in this case, this one was months. I could type in any number of months, and it will tell me how much money I have. So I wouldn't have to go through and type this whole equation in and figure out, like, and constantly do it. I could be like, all right, at 60 months, here it is. At 70 months, here's how much I'll have. At 100 months, here's how much I'll have. Like, I can do it real fast on the calculator once you type it in. Okay, that's the point of the graphing calculator, why you would want that. You could see at any point how much money you're going to have. Okay, but that being said, we will take off. We just won't look at that part of these next questions. Okay, so number 6, Robbie opens an account at a local bank by depositing $100. The account pays 2.4% interest, compounded weekly. He deposits $100 every week for 3 years. How much is in the account after 3 years? Okay, so do you use your regular compound interest formula or the fancy one?
Fancy one.
Why? Good. Every week he keeps putting more money in, so you got to use the fancier formula. Okay? So if we're going through, I'll tell you what, guys, I'll work it up here. You work it at your seat, write it down, type it in, see if you can get the answer, and I'll do it up here, and we'll compare. Problem. All right, last one, number 7, on your own. Number 7. All right, guys, if you're still working, just go ahead and finish up. I will go ahead and write up what I have, and you can kind of compare, make sure we did it right, okay? All right, guys, when you type it all in, you should get $13,537.79. All right, and then we won't worry about B, C, and D because that's talking more about the graph part, which we're not going to do. Questions on the formulas? I'll put it back up in just a minute. All right, guys, your assignment for tonight, let me pass it out, and then I'm going to mark off certain parts that, since we didn't do the graphing, I'll take off some of them, okay? So just hang tight for me. All right, guys, so on your assignment, so the 3.7 worksheet, you can skip, or go ahead and cross them off, 5B, C, and D, but you must do 5A. Okay, so you have to do 5A, but you don't have to do 5B, C, or D. And then you can cross off 7, B, C, and D, but you have to do 7A. And then 8, you can cross off D, E, and F, and cross off 9. Oh, is that G? Sorry, G. Sorry, I'd already crossed it off with Sharpie, so I couldn't read it. There we go. So cross off 5 B, C, D, you have to do 5A. 7 B, C, D, you have to do 7A. 8 D, E, F, G, you have to do A, B, and C. Okay, so I crossed off a lot. Keep in mind, though, as you get started on this, which formula you use, because regular compound interest is on here and this periodic one that we just did. So if you're reading the problem and it's just a one-time deposit, you use the regular compound interest formula that we started with on review today. If they are putting it in like every month or every week or like continuously, that's when you use the fancier formula. Okay? Comprende? Yeah? Okay.